Dr. Rick here. If you find yourself getting particular about where you get the weather, you may be turning into your parents.
Looks like it might rain. Let's see what Corey from Channel 2 has to say. He's something else. I like him better than Harris from Channel 5.
You could just look up the weather on your phone.
I like Corey from Channel 2.
Progressive can't help you from becoming your parents, but we can help you compare rates on home insurance with Home Quote Explorer. Progressive Casualty Insurance Company affiliates and third-party insurers. Comparison rates not available in all states or situations. Prices vary based on how you buy.
Hey everybody, and welcome back to another episode of JavaScript Jabber. This week on our panel we have Steve Edwards.
Hello from a very rainy Portland.
Dan Shappir.
Hi from a warm and sunny Tel Aviv, where it's in the high 70s all the time.
Oh, I'm so jealous.
AJ O'Neill.
Yo, coming at you live from SAD. That's seasonal affective disorder, by the way.
Oh, yeah, it's cold here. I'm Charles Max Wood from Top End Devs. And Dan, you scheduled this. I guess you got tired of us complaining about React.
Yeah, exactly. I kept hearing you guys talking about how React is kind of weird and strange and not understandable and really complicated, and how you guys miss the browser DOM. And I thought that maybe it has to do with a certain lack of understanding of some of React's core principles. And in particular, how the core philosophy of React, you might say, and how it's enabled by virtual DOM, which is obviously different from the real DOM because it's virtual. So, yeah, that's what I want to talk about today.
Hey, folks, this is Charles Max Wood from Top End Devs. And lately, I've been working on actually building out Top End Devs. If you're interested, you can go to topenddevs.com/podcast, and you can actually hear a little bit more about my story, about why I'm doing what I'm doing with Top End Devs, why I changed it from devchat.tv to Top End Devs. But what I really want to get into is that I have decided that I'm going to build the platform that I always wished I had with devchat.tv, and I renamed it to Top End Devs because I want to give you the resources that are going to help you to build the career that you want, right? So whether you want to be an influencer in tech, whether you want to go and just max out your salary and then go live a lifestyle with your family, your friends, or just traveling the world or whatever, I want to give you the resources that are going to help you do that. We're going to have career and leadership resources in there, and we're going to be giving you content on a regular basis to help you level up and max out your career. So go check it out at topenddevs.com. If you sign up before my birthday, that's December 14th. If you sign up before my birthday, you can get 50% off the lifetime of your subscription. Once again, that's topenddevs.com. I just think that the front-end frameworks are mostly overkill, but...
For a lot of use cases, they definitely are. I mean, if you're building a mostly static website, then all you really need is just HTML and CSS and have at it. But if you're building something that's more applicative, an actual web app, let's say, something that needs to be a single-page application, which is a whole discussion in and of itself, I guess.
Yes, it is.
Then something like a framework is really often the way to go, because it just does a whole lot of the heavy lifting for you.
I agree that if you don't use one, you'll build one yourself. And I do agree that most people don't document their code, so you'll be left with something that's worse than any alternative.
Yeah, for sure.
Yeah. My take on it is mostly that if you're building like an interactive experience, then the frameworks make a lot of sense. If you're building an interface that's relatively simple, that is mostly static,
contact form, a static web page with marketing material, and a contact form,
right?
For sure.
But I need the contact form to be dynamic and all that, so I really need a JavaScript framework for that.
And so you have to convert the entire page that otherwise would render without JavaScript at all, because there's literally nothing JavaScript does into a React app that then takes for.
Anyway, but I am curious because I've talked to plenty of people about React. I've built some React native apps. There are definitely some things that I like about React. It's just that when I'm reaching for, hey, I've got to build this out, typically I'm not building the kind of experience where I really need the kind of interactivity that React, Angular, and Vue tend to, I think, would push me to use one of those. So, but Dan, let's dive into this, because I really do want to talk about, what is the React philosophy? I mean, what are we talking about here with how React works, how React thinks about the web and things like that? Because a lot of people are using it. A lot of people like it. And though I disagree that they need to use it in every instance that they use it, there are reasons that people are using it. And so I think that's the value of diving into this. And I think there might be some pushback as far as, hey, that makes sense, but then it doesn't add up to using it here. But I think in other cases, it's going to also be, I hadn't thought of that before, so maybe I would reach for it in this instance where I wouldn't have before. And so I'm kind of curious just to have the conversation and see where we wind up, right? Because I'm betting that, yeah, you're going to dive into some stuff that I wasn't aware of.
I hope so. Yeah, we talked about it before the show that a lot of people are probably using React because that's simply what they've been told in a boot camp or an online course that got them into web development.
Mhm.
So that's effectively all they know. It's not that they chose React, it's that like React was chosen for them. And they don't even necessarily know or understand how the browser DOM works and the event loop and stuff like that. And that's really a shame because, as you said, in a lot of cases, the built-in functionality in the browser is just good enough. In fact, it's often better than good enough. It's exactly what you need. But there was a reason that React was built the way that it was. And the particular aspect of React that I wanted to dive into is the virtual DOM or the VDOM. And understanding the VDOM is fundamental to understanding the why and how of React. And in fact, the VDOM has been so successful that it has transcended React and has been adopted by other JavaScript frameworks.
Mhm.
So, for example, Vue uses virtual DOM, Mithril uses VDOM, and Preact, which is kind of an alternative React implementation, obviously uses the VDOM. And then on the other hand, you have other JavaScript frameworks that intentionally avoid using the VDOM. For example, Rich Harris, the creator of Svelte, has called VDOM on record pure overhead and effectively built Svelte in a way that it totally avoids using it. So there it cuts both ways. So
Yeah,
I definitely think it's worth a conversation.
So with the virtual DOM, my understanding is might be totally off base, but basically virtual DOM is a legacy of back from the jQuery days when the DOM wasn't efficient and we didn't have methods like insert adjacent HTML that were extremely performant, and we didn't have request animation frame, and we didn't have all of the performance tools baked into the DOM that now exist.
Well, that's not exactly the case, in my opinion, at least. From my perspective, there are a couple of problems with direct DOM manipulation, and performance, past or present, is only one of them. So other issues with direct DOM manipulation, historically, it has been browser compatibility. That one can be said to be effectively solved, especially now that everybody is dropping IE support. For example, I just learned that Lego announced that they're no longer supporting IE. Wix, by the way, treats
Lego, as in
yeah, the toy that you buy, Lego, they have a website, apparently a really cool one, and they used to support they used to support IE, and now they don't anymore. So hooray
well,
for them.
I'm glad that they realized that people that work at banks and government facilities aren't their target customer.
See, when you said that, Dan, I thought for a minute they weren't shipping it as part of their Lego toys, the little computers that they ship. So.
Yeah. And by the way, Wix we also treat Lego as a legacy browser. So if it kind of happens to work, then great. But we actually put in a notification that we don't officially support it anymore.
Wait, Lego has a
I think
browser?
you just misspoke and said we don't support Lego as a legacy browser, which is hilarious, but we all know what you meant.
Yeah, I meant IE.
Fair enough.
Yeah. But historically, one reason for frameworks has been browser compatibility. And like I said, that one is gone. So
well, that was initially the issue that jQuery was built to solve. And prototype before
sure.
that, right? It was, well, we don't know if we call this, if it even exists, right? Because Microsoft made their own APIs, and then we're just going to wang it out there and hope that it works. And so jQuery made it consistent, which was so helpful.
And now the browser makers really do work hard in order to adhere to the standards and make sure that the standards are such that they can all adhere to them.
Mm-hmm.
Okay, so if not browser compatibility, what then? What are other problems with the browser DOM itself? So I think the key issue from my perspective with the browser DOM is that it's effectively mutable global state. You essentially, any part of the code can access any part of the DOM at any time, and you manipulate it using side effects. So you invoke a JavaScript function. That JavaScript function, I don't know, does a query selector, whatever, finds the DOM node that it's looking for, and then manipulates it, and then doesn't actually return anything from that function. It's all side effects. It's all globals. Any part of the code can access almost any part of the DOM. These days we have the shadow DOM and stuff like that, but effectively you can access any part of the DOM from anywhere. And if you can't do something, developers tend to do that thing. So you end up with code that really any part of the app might be doing anything with any part of the DOM at any time. There's no clear separation of concerns. And this becomes especially problematic if you start working with asynchronous code. So you start modifying some part of the DOM, then you wait for some JSON to arrive via Ajax. And in the meantime, some other part of the application manipulates that same part of the DOM, and you end up in something that's totally inconsistent. So that's the key problem with the browser DOM. Now, obviously, if you're not doing very significant manipulations, or alternatively, if you're writing really clean code, then you can work around this limitation. But if you're writing complex applications, you do want to avoid this type of an approach. You want to have componentized, you want to have code, you want to have encapsulation, you want to have separation of concerns, and generally avoid side effects.
Gotcha. So everyone but Steve will have this problem. Steve's code is perfect, but the rest of us?
Yeah, exactly. Also, the DOM tends to be complex. It's highly imperative. If you end up with really verbose code to do some things that seem to be really simple. You create a DOM element, and then you need to set the properties one by one, and then append it.
False information, fake news. You do not need to do that. That is how it's commonly done, but you do not need to do that because you can just construct a string and use insert adjacent insert adjacent HTML, insert adjacent element HTML. I forget what it is.
Yeah, I'll get to that in a bit. But yeah, that's, kind of quote unquote cheating in that effectively you're treating a string as a piece of code. It's a legitimate thing to do, but it also has its own risks and downsides.
Wait, have you ever heard of React?
Okay.
I just want to point out the hypocrisy while we're here.
Okay. We'll get there. And another issue that I wanted to mention about direct DOM manipulation is that it's really problematic to test, or at least it can be, because you usually end up doing a whole lot of mocking in order to simulate the DOM so that you can modify that simulated DOM in order to test your code. And mocking is just not a lot of fun.
Do you find, because I just assumed that the only way to test front-end code in any way that brings real value is to use something like Cypress. I had never considered that it would be desirable to try to test. Well, I mean, I really use React, but I'd never considered it to be desirable to try to test DOM manipulations without testing how the browser actually behaves because it's so likely to do something you didn't expect.
Well, again, if you properly break down your code into components, and certain components are really small, and you can actually implement it as something like pure functions that receive a state value and emit HTML in a way that you can check that HTML that the function provides as a return value, then why isn't that testable?
Because as soon as you put that on the page, there's some other component that overlaps with it by a padding of 30 pixels, and you can't click the X button or get rid of the ad or even subscribe to the newsletter. I'm not saying to avoid end-to-end tests. I'm just saying that those are extreme cases and you should definitely test for them. But in each and every component, there is a lot of value to unit tests. Let's put it this way. Yeah. And if you can actually unit test the front end, that's a huge benefit. Anyway, it's really up to you. But one of the problems with working with the browser DOM directly is that unit tests, if you do want to implement them, become really difficult.
Now, I have to point out that it actually used to be very simple because in the past, if we wanted just the HTML to be kind of not implemented as side effects of JavaScript functions, well, what we would do is just do it all server side. And then you just make a function call, quote unquote, which is an HTTP get or an HTTP post if you have parameters that you need to provide, and you get the HTML back as a return value because it's the response, and that's it.
I still like that way of doing things, to be honest.
Well, that way is great. It's great when it works, but there are obviously some problems with it. I mean, if your network isn't great, or sometimes even if it's pretty good, it still can be relatively slow because of the network round trip. For some interactions, it's not a problem, but for other interactions, having that network round trip, let's say if you want to create some sort of interactive form that does things whenever you click or type something, for example, something like the Google Smart Search box, you won't do that by reloading the page on every button press. It just doesn't make sense. And another big issue with this approach is that you lose local state whenever you reload the entire page. So even if you load the page that looks exactly like the page that you left, all the forms would be cleared. You lose whatever state you had locally within the page when the new page loads. So there are reasons why in some cases an SPA is better than an MPA, at least in portions of the web application.
Did you just say MPA?
Multi-page application.
I know. I just thought it was funny. I've never heard it before.
Oh yeah, well
I've never heard the term before. Yeah.
Interesting. Live and learn. So this is what React creators were looking to achieve or to solve. How to get the benefits of an SPA on the one hand and couple it with the simplicity of an MPA on the other hand. And here I used it again. That means create this sort of a mechanism where you get back the DOM that you need as a function return value, kind of. Now, it turns out that if we do want to achieve that on the client side, there are actually several ways in which we can do it. So one way is that we can, in fact, like AJ kind of suggested before, essentially just have that function return an HTML, a string. Just return a string containing HTML and then use something maybe is even as simple as inner HTML or like the new append adjacent HTML. I forget the exact DOM API, but you can definitely use that and it definitely works. So like I said, you just create this JavaScript function which gets this whatever state you need to provide to it as parameters, return HTML as a string. Let's say you invoke that following some user interaction, and then you assign that HTML into some element in the existing DOM. And it's really easy to implement because now we also have JavaScript template strings. So it's really easy to insert your values into some sort of a string literal that you prepare in advance. And another advantage is that you can actually even break it down into sub-functions. And each one of those can return a partial string, and then you can just concatenate all those substrings into this one big string, and there you go. So you've got the benefits of the server-side mechanism. In fact, it works in a way that's really similar to it. You avoided the round trip. You also don't need to reload the entire page with all its resources and all the JavaScript because you just set that string into a part of the page, and you don't even need to modify the entire page. You can just modify those parts that need to be modified, so the state in the other parts is untouched. And the benefits are that it's pure functional, it's params in, string out, it's very declarative. It's easy to compose. Like I said, you just concatenate the strings, and it's really easy to test as well because you just, test the string that you get back. You don't need to apply it into an actual DOM or a mocked DOM in order to test it. But it also definitely has downsides. First of all, it's surprisingly fast because browsers are really, really good at parsing HTML strings, but it can still be too slow, especially if you're trying to set really large portions of the page. For example, I probably wouldn't want to do that if I'm trying to maintain a 60 frame per second frame rate. I wouldn't set the entire page over and over again using HTML strings. Those portions of the page that do contain local state, if you do an inner HTML, for example, into their parent, you do lose their local state. So even if you replace one text box with another text box, the content of that text box is gone. And obviously, there are the limitations of using strings as code because you don't really have syntax checking, for example. So I know that there are some VS Code extensions these days that kind of address this, at least to an extent. But still, at the end of the day, when you put code inside the string, you lose a lot of the safety that goes with the validation of that code. So, for example, if you generate wrong HTML, the only thing that you'll notice really is that the page renders wrong. There won't be any syntax error or anything like that. So that's one possibility. Another possibility is to actually have a function that generates an entire DOM subtree, maybe something with a document fragment or maybe just some root element or something. You just use JavaScript code with direct DOM API, create element, set attributes, all the stuff. And then you return that DOM fragment as the return value. And you can use something like the new replace with DOM API to replace the existing DOM node with the new DOM node. And again, you can even break it down into sub-functions. You just append the results of the sub-functions, inside the main function. So that's another approach that you can take, which doesn't require anything beyond what we already have built into the browser. But, despite what AJ said, this can end up being really verbose. I mean, unless you're using the HTML shortcuts, string shortcuts, in which case, we already spoke about that, then you end up with really verbose code. For example, you create an element, then you set the properties one by one, then you append to the parent. Lots of instructions in order to create each and every element. Again, if you replace an element, you lose the state of the previous element. And the funny thing is that it can even be slower than the previous method of using an HTML string. I know that people might be surprised by that because they think, hey, the browser doesn't need to parse a string. I just give it the exact DOM elements. But it turns out that performing a lot of DOM operations from JavaScript can actually be very expensive.
So
we've talked about this in the past.
I'm not sure about this, but I would assume that if you do the operation in a request animation frame, you would get some benefit because then the browser knows that you don't expect it to cut its other processes to try to repaint. Because the reason that doing the manipulations has traditionally been so bad, my understanding is that because the browser, every time you manipulate a node, the browser will repaint. Whereas if you use the string, the browser doesn't repaint until it's completed the entire node all on its own.
No, that's not correct.
Okay.
The browser, first of all, if you create a DOM node which is currently not attached to the document, you just create it and then modify it, so it's at present not yet attached to the document. Anything that you do with it doesn't cause any rendering whatsoever because the browser knows that it cannot impact the display. So it's actually, in most cases, beneficial if you do use direct DOM manipulation. And I have the dog barking here. If you're using direct DOM manipulation in this way, it's actually beneficial to do as much of the DOM manipulations before you attach the DOM node to the document. So that's not one thing. The other thing is that if you don't interleave operations, that is, you don't read, write, you just write, and then read, or vice versa, then you can also, the browser can actually batch the updates. But hopefully we'll get to that a bit later on. So we spoke about two possible solutions. So let me propose a third one. And the third one is actually the virtual DOM. And here it goes. Let's say that instead that I take the similar approach to the one that I just presented, but of creating DOM elements, but instead of creating actual DOM elements, I create JavaScript objects. And the JavaScript objects kind of mimic or stand-ins for actual DOM objects. So what I'm saying is that instead of constructing actual DOM elements, we'll simply construct lightweight, simple JavaScript elements. You can think about them like JSON effectively, where each of these elements represents a single DOM element, or each one of these objects actually represents a single DOM element. You might have a string field on that object that specifies the tag name. You'd have an array of attributes or a map of attributes, key value pairs. And then you would have an array of children, which are also just more JavaScript objects. So effectively, it's just a JSON. And instead of returning a DOM element, we return the root object of this tree of JavaScript objects that we just constructed. And as we all know, if there's one thing that JavaScript is really good and fast at, it's creating and manipulating its own objects. So JavaScript can create objects really quickly, add properties on top of them really quickly. We can also provide a factory function, which makes this really easy, or we can create it as object literals, whichever way we prefer. Either way, it's all good. But you then might ask, well, it's really great that you created this JSON, which represents the actual DOM, but still needs to be converted into the actual DOM in order to actually do anything. And, for the first time, that's exactly what happens. The first time that you render, it's up to what the library that you're using, in this case, React, to take this tree of objects and actually just convert it into an actual DOM that exactly matches in terms of content the tree of objects that you handed over to it. But after the real DOM is created, what React does, it actually holds on to that tree that you gave to it. It doesn't just discard it. And then the next time that you give it a new tree, what it does is it then compares these two trees and checks and identifies exactly what the differences are between these two. And it kind of creates a list of all the differences. And then only those differences are applied into the actual DOM. And then, of course, you take that new virtual DOM that you created and use it as the base for the next time and discard the previous one. And this process, by the way, is called reconciliation. It realigns the browser DOM with a new virtual DOM by making the least expensive changes in the actual browser DOM so that it matches the new virtual DOM. Is that clear so far?
Mm-hmm.
So effectively, you've got this, theoretically, you would have this pure function, you give it a state, it builds this tree of JavaScript objects, hands them back, you take the root object of that tree, you hand it over to React, and React uses that to update the DOM by just changing those parts of the browser DOM that don't match this new tree. The benefits of this approach is that it's really fast because, like I said, building a tree of JavaScript objects is really cheap. And also you make a really small, usually, except for the first time, you would usually make a small number of changes in the actual browser DOM. It also preserves the DOM state because anything that hasn't been changed is just not touched in the browser DOM. And it's easy to use because building JSON is simple. So, it's really easy to do. I do want to say a few words about this reconciliation, about how it works. Like I said, it works by comparing two trees in order to discover the differences between them, or more precisely, the smallest number of operations required to get from the second tree to the first tree. For general purpose trees, such a comparison would actually be pretty expensive. I didn't research it myself, but the React documentation says that a generic tree comparison algorithm would be a big O of n to the power of 3. So it's pretty expensive. So in order to avoid such expensive operations, what React does, and the same goes for the other frameworks, is that they use shortcuts. Based on the fact that they're not comparing generic trees, they are comparing trees of HTML elements. So they reduce the complexity because they can make certain assumptions about the trees that they are comparing. For example, if, let's say, they hit a certain element in the new VDOM tree, and it's of type, let's say, span, and in the previous tree, it was of a type div, then they know, hey, the element type itself has been changed, well, then it doesn't try to do a comparison of the subtree from that point on. It just assumes that, okay, everything here has changed. I'm just going to replace the old one with a new one. So it just has to recreate that entire DOM browser DOM section, but it reduces the complexity of the comparison. There are also special handling for certain attributes like style, because it actually has to look at the various parts of the style and not at the style in its totality as just a string value. And there are other tricks in there that maybe if we have time, we'll get to later, like using keys and stuff like that to help the algorithm do its matching of which object matches which. And that's the whole trick of the virtual DOM, really. The fact that thanks to this approach, you can have a pure function that takes state, returns the DOM that you want the browser to have, but as a whole, but not as an actual DOM, but as JavaScript objects, which you can then hand over to React, which does the minimal amount of changes in order to get to that desired HTML state. That's also one of the reasons why you should generally avoid modifying the DOM behind React's back, because it assumes that the state of the DOM matches the previous virtual DOM that it has. If you then just went directly to the browser DOM and did all sorts of modifications, then obviously React wouldn't be aware of it, and you would end up with potentially inconsistent states. But if you've ever read React code, you probably say, "But hey, Dan, you're talking about simple objects and it's JSON and whatnot. But if I look at how React code is written, I don't see JSON objects. I see something that looks like HTML, which is obviously JSX." And that's kind of React's second, let's call it idea, or you can decide whether it's smart or not yourself, which is to they were basically saying that it would be very unnatural for people to write create the VDOM using something that kind of looked like JavaScript objects. That people generally prefer to build HTML as something that looks like HTML. And I guess they were looking at the templates that were available in other frameworks like Angular, for example. Mm-hmm. So their idea was to use something like that, but to effectively embed it within the JavaScript itself. And they did that by implementing a transpiler, or you can call it a compiler, or maybe even just a preprocessor, whatever you prefer, which takes something which looks like HTML declarations, and then it converts them into JavaScript objects. Well, more accurately, it actually converts them into function calls that generates JavaScript objects. But essentially, it's the same idea. So you kind of ended up with something that's kind of like HTML embedded in the JavaScript itself, or you can call it HTML and JS or something like that.
Hi, this is Charles Max Wood from Top End Devs, and lately I've been coaching some people on starting some podcasts and in some cases just taking their career to the next level. Whether you're beginner going to intermediate going to advanced, whether you're trying to get noticed in the community or go freelance, I've been helping these folks figure out how to get in front of people, how to build relationships, and how to build their careers and max out and just go to the next level. So if you're interested in talking to me and having me help you go to the next level, go to topenddevs.com/coaching. I will give you a 1-hour free session where we can figure out what you're trying to do, where you're trying to go, and figure out what the next steps are. And then from there, we can figure out how to get you to the place you want to go. So once again, that's topenddevs.com/coaching.
And in many ways, it seemed like sort of a perfect solution. You can write pure JavaScript functions that accept state as parameters, return the VDOM, hand the VDOM back to React, and it efficiently reconciles it with the actual browser DOM, and job done. And whenever you need to update the browser state because the user did something that needs to impact the UI or some information arrived from the server, well, you just call that function again. So theoretically, if we went with a really simple solution, all you would need to have is your own function, which builds the virtual DOM, get that and take that virtual DOM and just pass it as a parameter to some React function and job done. But we all know that React is not that simple, because there were several problems with this really simple approach. And this is where I like to say that this is when reality happened. You had this really, really cool and simple solution, and then you started running into all sorts of limitations with it. So, as I mentioned, the initial state is still expensive because there's nothing before the initial state. So that one still needs to be created from scratch. But let's put this one aside. We'll get to that later, hopefully, if we have time. And the other problem is that even with reconciliation, this process can be slow, and I'll explain why. And another issue is how to manage local state, because the function that I described that takes state and returns the entire VDOM as a return value that you hand over to React, that state is a global state. But let's say I want to have some sort of a local state. Let's say I have a form and I have this checkbox that controls whether you see the state or you don't see the state or something like that. I'm talking about states in the U.S. in the case of the form,
Okay.
or yeah. So you kind of modify how the form looks like based on the values of other fields. And that doesn't seem like something that which should reside in a global state. That's something that seems like local information to a particular component in the user interface. So those are the problems. But so like I said, the initial state is expensive. Let's talk about that a bit later. Let's talk about why I'm saying that even with reconciliation, the updates can still be too slow. So I previously explained how the VDOM is really cheap and reconciliation is really efficient, and the React developers are really smart, so they use the really sophisticated algorithm. And if their algorithm isn't efficient enough, you can use Preact, which is even more efficient. But what about your own application's logic? I mean, that function that takes the current state and maps that into the VDOM, that's still potentially a lot of work. If your UI is complex and there are enough elements in the page, and you need to run the logic for each and one of those elements. And in some cases, it's simply a question of quantity. If you have a lot of components in the page, then running the logic for all of these components can be really expensive. I've seen blogs, for example, implemented where almost every line in the blog was a React component. So if you've got a long document, that's just a ton of React components that you need elements in the VDOM that you need to generate one after the other. It's just a lot of work. Or potentially, maybe there are not so many objects in the VDOM, but some of them really depend on complicated logic that takes a while to evaluate. And running all of them, all that logic, your own code on each and every update can be expensive, again, especially if you're trying to hit something like 60 FPS. So there are certain tricks that you might use to reduce this overhead. For example, one trick that React introduced relatively early on is, let's say that your function, or a function that's supposed to generate the VDOM for a certain section of the page, let's say that instead of just getting the current state, it also receives the previous state. And it can then compare these two states. And if it sees that they are equivalent, that they should generate the same VDOM, then it could simply cut off without generating the VDOM, without invoking all its children. It could just stop and maybe return some sort of a value which indicates I've stayed the same, all good, nothing to do with me. It will also reduce the reconciliation time. So that sounds really great, but it's kind of difficult to implement as a simple function. I mean, what would you return if you want to say everything is good with me as a function return value? I don't know. Maybe you'd think, hey, I just return null or undefined, but turns out that those are actually legitimate values to return that mean I don't have a VDOM. So they would actually need to return something else. Like I said, implementing something like this as a pure function, which just returns a single value, is problematic. So maybe you return two values, but then you make the whole thing just more complicated. So that's one problem with it. Another problem is that sometimes comparing the state can be in itself complicated and expensive. And then you might be doing more harm than good, because for every one of these components, you're doing both the comparison, and then if the comparison turns out to be false, the actual generation. So now you're paying an even bigger price whenever you need to actually modify the virtual DOM. And you still need to go through all the parents' elements in all the ancestors in the tree to get to that point where you do the cutoff. So bottom line is, it's a cool technique. It can be really useful in some cases, but in a lot of other cases, it's just not enough. We need other mechanisms where we can control which portions of the virtual DOM we actually want to generate. But again, you see the problem here. Originally, the concept was so simple because we said, hey, we were just going to recreate the entire virtual DOM on everything. And then the model was indeed really simple. And now I'm getting into the weeds because I'm coming up with ways in which I can generate just portions of the virtual DOM instead of the entirety of it. So yeah. Any thoughts or comments so far?
I'm sold on the basic idea of the virtual DOM, more or less. I think a lot of times when people have complained about, okay, so with AG Grid, for example, they do weird stuff that cannot be accomplished with direct DOM manipulation. We had them on the show. They talked about it. That makes sense. It seems to me that, and this is kind of this is definitely a tangent from the main conversation, but just the argument about the virtual DOM. I get it, but I also question if the need for the virtual DOM doesn't suggest that something else in your process has gone really wrong. So, for example, in Angular, if you wanted to fill a list dynamically with, say, as you type, you want an autocomplete to fill. The reason that this was ridiculously slow in Angular was that it would regenerate the entire list on every single keystroke, right? In the naive implementations. And so if you just used a little bit of smarts to make sure that you were generating your list and then filtering it down, then you would get the advantages that you need, and it wouldn't be ridiculously slow necessarily. And when I think about most web applications, typically you're just dropping in a component, something new. You're adding a pop-up. You're making one or two small changes to the page. You're not making hundreds or thousands of pages or changes unless you're doing something like a virtual table and virtual scrolling and all of that. In which case,
but again, AJ, you're looking at it from the perspective of performance, and the perspective that I'm trying to take you to is a perspective of updating the UI as through pure functions, state in, DOM out, and think about it this way.
Okay.
When you're working with Angular, one of the complaints about Angular back in the day was that something changed, and it was really difficult to determine what actually in your code actually changed it. What was the cause of that change? And because things could be changed from all over, and the state itself of the UI was mutable, you kept mutating the state. And if you made a wrong decision somewhere along the way, then you would end up with an incorrect UI state. And it, like 10 steps down the line, it would be really difficult to determine how you got there. Whereas with React, you just take the current state, generate the fresh UI as if you went to the server and got the whole page back. You don't have to think or worry about what the previous page looked like. The only thing that React does with this virtual DOM is that it tries to make this actually doable by reducing the cost of replacing the previous DOM, updating the browser DOM from the previous situation to the new one. So you don't look at it as mutable. You just look at it as state in, DOM out, and React converts that into a series of mutations. And because it's React, it's created by really great developers, you can assume that they wrote the code correctly.
Okay, so
that's the basic idea.
I get that. So let me repeat what I think I'm understanding. So let's say that we have some terrible ad widget on the page and it has a bad selector and it goes and edits something that it shouldn't edit. With React, once the user clicks a button again, it's going to re-render from its object of what the state is, what the state should be. And so the fact that you had an ad widget or an analytics widget or whatever that screwed up your page in some way that you didn't expect and would be a nightmare to debug, that bug is only going to persist for a short time, and then it's going
to again, actually not exactly true.
Okay,
because
not like I said,
yeah, because again, like I said, if you actually modify the browser DOM behind React's back, React is not aware of it. React just writes to the DOM. It doesn't read from the DOM unless from the browser DOM, unless you. So if you have a widget that went behind React's back and actually modified a part of the browser DOM that it shouldn't touch, that page could persist unless React happens to write to that same place as well.
Well, that's what I'm saying, is that React is going to rewrite that thing because you're going to do something on the page and it's going to rewrite the form, or it's going to rewrite the list. Or so if something is buggy, it's less. If something outside of the React is acting on the page, outside of the code flow that you understand is acting on the page, then that is going to be less of a problem.
I prefer to think about it slightly differently. Think about the fact that your UI can be in a whole bunch of states. And in the Angular type of an approach or direct DOM manipulation, you can get from any state to any state directly. You just supposedly mutate your state to get from state A to state B. And then you mutate your state to get from state B to state C and so forth. And if you made any mistake along the way, then instead of going from A to B, you get to B prime, and which is almost like B, but not exactly. And then when you move from B to C, because you're not from B, you're from B prime, you get to a state that's not exactly C either. And the errors kind of accumulate, and pretty soon you're seeing something really weird on the screen, and it's really difficult to figure out how you got there. With React, whenever you don't go from A to B, you always get back to that virgin state. And because you're taking your existing current state and generating the entire VDOM from it, at least in the naive approach. So you're always starting from fresh, as it were. Like I said, think about it sort of like what they were looking at is how the browsers used to work when they would hit the server and get back the HTML. Whatever you screwed up in the previous page, that was gone. And again, I'm not looking at some third-party component that you don't have any control over. I'm talking about your own code.
But wait, if I wrote buggy code, wouldn't it still be buggy though?
Yeah, but again, it's much easier to think about going from fresh to state instead of having to think about and measure and monitor all the possible states that might exist in your application. It's, every state transition that you implement is something that you potentially need to think about, to test, to make sure that it works correctly.
Right.
If you have like 10 possible states and you can get from any state to any state, those are 10 to the power of 10. Those are 100 different types of transitions that you need to figure out, to implement,
I think you meant a quadrillion.
Well, no, it's not 10 to the power of 10. It's 10 times 10 because you can get from everyone to anyone. You're correct. But on the other hand, with the React approach, there are only 10 possible transitions. You always go from the fresh state to one of those target states. So it would be 10 transitions. Now, obviously, in a real application, there are not 10 possible states. There are, 10,000 possible states. Now, obviously, you can't get from every state to every state. So it's not 10,000 times 10,000. It's just 10,000 times, times 100. So it's 1 million different state transitions that you would need to validate. Whereas with React, it's just those 10,000 because you always start from fresh. That's the key. So don't think about it from the perspective of performance. Because look, at the end of the day, anything that you can do with React or with any framework for that matter, you can just do with the plain old DOM. Because at the end of the day, all these frameworks are just built on top of the DOM. So DOM manipulation can be done as efficiently, if not more efficiently, than any framework. It's just the frameworks make it easier for you to potentially write, correct code.
Okay, so Essentially, it gives you a sandbox to operate in, and the constraints define the art. Therefore, if you have certain constraints that you operated within, you only have a certain way that you can write the code, and you limit yourself to ways of writing the code that are more functional and therefore easier to test and debug.
And to also reason about.
So this is where I have a hard
state in HTML out. I would argue that pure functional code is always easier to think about and understand than code that is based on mutating a global object, a shared global object.
So if you're pitting against the extreme, then yes.
Well, obviously,
if you apply no constraints to your code style and say everything's fair game at the global level, then yes, I agree that if you intentionally exercise no constraint or code style versus you exercise any constraint or code style, including the functional paradigm, then yes, I agree that it is easier to reason about. However, my primary gripe with React is that it is nearly impossible to reason about because, one, it's not JavaScript. It isn't. It is not JavaScript literally in the textbook definition of what a language is. React is not JavaScript. And it doesn't use patterns that are familiar to JavaScript. And this is said very well in Abramov's talk, React to the Future, where he totally says, agree. In essence, the problem with React is JavaScript. We could only get so far away from JavaScript. That's not exactly his wording, but that was his message, is that React's great. The problem is JavaScript.
I wouldn't take it that far, but I totally agree with what you said. I kind of agree and disagree because, on the other hand, as we all know, I really love JavaScript. I'm on a JavaScript podcast. I'm a JavaScript fanboy. I definitely don't want to get away from JavaScript. And you're correct. And I don't recall reading that post by Dan Abramov, so I can't comment on it directly. But it's definitely true that JSX is not JavaScript. But on the other hand, it's in a lot of ways, React is JavaScript centric because everything is done within JavaScript files. And the JSX is embedded within JavaScript functions. And definitely you're using different paradigms, but they're all implemented in JavaScript. Whereas other frameworks really walk away from JavaScript. If you look at like Angular or Vue, they have their own templates, and their own kind of templating language, which is totally not like JavaScript. So you're writing conditions and loops within your front-end application in a totally different programming language. While in JavaScript, if you do a loop, it's probably implemented using something like a map function or something like that. So it's kind of interesting that on one hand, you're definitely correct that it's not really JavaScript anymore because it's JSX. But on the other hand, it's still in a lot of ways really JavaScript centric. So, take it any way you like. But the point is, the key point I was trying to make is that the VDOM was created to make things really simple. In an ideal world, they would have been, but then you ran into these three problems that I mentioned. One is the initial state, which, like I said, we'll get to later. The other one is that even with the VDOM, it can still be too expensive to do that entire generation of the VDOM and the whole reconciliation on each and every change. You need to have shortcuts. And the third one was that you do want to have some sort of a local state, whereas the model that I described so far, that function that generates the VDOM just takes the whole global state. So you keep everything in the global state, and that's obviously problematic. And I presented one way to reduce the effort of generating the VDOM, which was by having the ability to do some sort of maybe a cutoff, saying that the state that you got when compared to the previous state that you had on the previous invocation would generate the exact same VDOM, so there's no point in continuing. It can be a great optimization, but as we saw, it's actually difficult to implement using pure functions. And indeed, when React implemented it, at least originally, they did it via classes. So you would implement a method on an object which would be invoked in order to do the comparison, and then it would invoke a different method. If the comparison returned that rendering is still needed, it would invoke a different method in order to actually return the generated VDOM. But the other problem with it is that it can sometimes reduce the overhead, but in some cases it can actually introduce overhead because even the comparison itself can be fairly expensive. Let's put that issue aside for a minute and let's talk about the problem of the local state. Where can I put the local state? Because one approach is to avoid local states, and some React developers...
I'm going to interrupt you here for a second, Dan. We're already at an hour recording. I have a hard stop in 20 minutes. So
yeah,
how much longer are we going to go?
Yeah, probably another episode, I think.
Probably. All right. So we'll just kind of put a pin in this here. We'll schedule a follow-up episode, do a part 2. And yeah, this is really fascinating. I mean, a lot of this stuff I'm aware of, but anyway, I really, really enjoy just kind of seeing where you're coming from on this, Dan. And yeah, some of the stuff makes sense. Some of the stuff, it's like, okay, again, I would use this in certain circumstances and not others, but I'm really enjoying it.
Oh yeah, for sure. If I only have really a small amount of DOM nodes that I need to actually browser DOM nodes that I actually need to modify, then a solution like that is a total overkill. And I can just write simple vanilla JavaScript and browser DOM and be done with it. And like AJ said, if I'm really organized about the way that I write the code and kind of push the code that does the DOM manipulation via side effects to really specific functions and make sure that certain parts of the DOM are only modified by those functions, then again, I can write pretty clean code. It's just that in reality, my experience is that unfortunately developers are not that organized. That if you have this global state that you can touch from everywhere, then the developers, they're under pressure. They create technical debt. They take shortcuts. I need to modify this part of the DOM, and it would be really difficult for me to call this whole sequence of functions and modify stuff all over the place. So I'll just reach out to the DOM and touch it from here, and job done. And eventually you end up with a big mess.
But tomato potato, because the React code that I've seen is a big mess where it's a bunch of people just use, and I get the argument, well, you're not really coding React if you're using Redux or whatever. I get that, right? But people just throw in these extra state management tools, and then they throw the state everywhere, and then everything is entrapped with the drippings of the state. And I don't see how that's any better than you need to be a disciplined coder. The React isn't going to solve that problem.
I totally agree. Yeah. Agree with everything you said, AJ. And yeah, React is no silver bullet. And if you write a messy code, then you can definitely write messy code in React. And my issue, and the one exactly that I was trying to express in this in our conversation, is that if you understand the React approach, the React philosophy, and try to write your code accordingly, work with React, instead of just writing on top of React, then you would probably end up with much better and cleaner code.
Agree with that. I think the same applies for the DOM, but I agree.
Fair enough.
I'd much rather people get good React training and write good React code than not get good React training and write bad DOM code.
Fair enough.
All right. Well, I'm going to push this into picks just in the interest of time. And yeah, we'll definitely revisit this in a future episode. Hey, folks, if you love this podcast and would like to support the show, or if you wish you could listen without the sponsorship messages, then you're in luck. We're setting up new premium podcast feeds where you can get all of the episodes released after Christmas 2020 without the ads. Signing up will help us pay for editing and production, and you can go sign up at devchat.tv/premium. Steve, why don't you start us off with picks?
Alrighty then. So I came across a site that's right up my alley. It is a phrase generator, or a catchy headline generator. And it says, the description says it generates random clickbait titles for your blog or magazine articles. And then it has different categories like academic quotes. It even has Bible quotes, which is sort of funny. Financial advice, headlines, and there's just random button and you push and you get a new headline. So like 5 jaw-dropping secrets that make supervisors stronger. There's political rhetoric. Says, I refuse to support an America where corrupt labor unions and greedy insurance companies can undermine our big box retail stores. Or the Bible quotes is great. They that praise the Lord thy God shall cast out lust and vice. They shall banish wickedness. Just quotes that you won't find anywhere, but it can come up with some really funny ones. So it's at phrasegenerator.com. And then for my highly anticipated jokes that I provide every episode. Question: what is the difference between a cat and a complex sentence? A cat has claws at the end of its paws, and a complex sentence has a pause at the end of its claws. Thank you. Thank you very much.
Been muted in time.
And then...
that was actually pretty good.
Why do birds fly to warmer climates in the winter? Because it's easier than walking. And then finally, last one. Went to my doctor the other day because I wasn't feeling well. And I said, Doctor, man, I got a bad case. I have a case of diarrhea. What should I do? He said, buy a new case. Thank you. So those are my picks for the day.
All right. AJ, what are your picks?
So first, I will pick the React to the Future talk. I was wrong. It is not by Abramov. It is by Jordan Walk. Is that the person that actually created React?
Yes.
Okay. So even better. Because this is the person who actually created React, says the problem with React is JavaScript. And it's a talk on reason. It's a clickbait talk because you think that it's going to be about React, and then it's React sucks because JavaScript. Reason is going to be the solution. Well, not React sucks, but React is crippled because of JavaScript. Reason is the solution. It's kind of what the talk's about. I only made it about halfway through. Then I got too angry, but put that there for people to listen to it if they want to hear the words of the person who created React. I'm also going to pick a couple of books. I'm going to pick 3, actually. I'm going to pick, well, I guess one's not a book, but Tribal Leadership is perhaps one of the most beneficial books that I have listened to in a long time. And I think it's one of those ones where I am not advanced enough as a human being to be able to digest it in one go, but it's essentially about the way that humans work together. It's not a framework. Many of the business books out there present a framework for how to work together, such as doing sprint being an example that programmers are familiar with, or different methodologies. And Tribal Leadership is not really about a framework. It's about, this is what people actually do, and these are how we give. It's those researchers, it's the words that they give to describe what they've observed about how people work together and what works best and what doesn't. And they describe it in stages, stage 1 through 5, where stage 1 is life sucks. Stage 2 is my life sucks. Stage 3 is I'm awesome. Stage 4 is we're awesome. Stage 5 is life is awesome. And those don't sound like descriptions of people working together, but if you get into the book, it does. And basically everybody's at different stages and might be at different stages within different tribes about how they feel. And this is, it's just identifying how teams that work well together and give some suggestions about how to move either your whole team or a subgroup of your team from one stage to the next stage. And so I think that it's quite valuable, perhaps one of the most valuable books that I've ever read, if I'm able to internalize it and kind of tease out those practices, because working with people is what makes life awesome or terrible, or both. The next one that I'm going to pick is Innovator's Solution, which would have been probably if maybe Tribal Leadership takes my new number 1 position, then Innovator's Solution may be dropping to number 2. And Innovator's Solution is just a book about, well, business. So if you're not interested in business and innovating, then, maybe it's not for you. But there's another book of a similar name. There's actually 3 other books of a similar name, but Innovator's Solution is the most important one. It's not the one that's most famous, but it's the one, obviously by its name, Innovator's Solution. This one is the one that has the answers, whereas some of the other books are more a different approach, which I won't say their names just so that you get one thing stuck in your head, which is solution, and you don't get confused by 2 things. Other than that, oh yeah. And then if you've got insomnia, I found this this meditation. I don't necessarily like listening to it, but it has been incredibly useful for me to actually fall to sleep. It's called a meditation for healthful sleep, guided imagery to reduce insomnia and improve quality and quantity of restful sleep by Belaruth Naparstek. So I'm going to give a link to that because I always listen to it and think, oh, how am I going to fall asleep to this? This is not that good. Why do I like this so much? And then I always fall asleep. So it works. And then other than that, normal stuff, creedsofcraftsmanship.com, at CoolAge86 for following live streams, at _beyond code for following the more high value material that I produce from time to time.
All right, Dan, what are your picks?
I only have just the one pick. So one of my colleagues at Wix is this awesome guy called Gal Schlesinger. He's into a lot of really cool stuff, into WebAssembly and Rust. I really need to get him to come on the show sometime. One of the things he likes to play with is TypeScript, and he takes TypeScript to the extreme. Because, when you're throwing generics and stuff like that into the type system itself becomes its own programming language. And so he wrote this post called Typing the Technical Interview in TypeScript, in which he uses TypeScript's own type system to implement the old FizzBuzz problem. So he implements a solution for FizzBuzz using just the TypeScript type system. Really interesting, really amusing article, highly enjoyable, at least I found it so. And like I said, I definitely need to get him on our show. And this would be my one and only pick for today.
Awesome. I'm going to go out with a couple of picks here. So the first pick I have this infection in my foot. It was bad. I'm going to pick antibiotics. The infection's gone. The pain's gone. Life is good. The other pick that I have, usually I listen to books while I work out, and I haven't been working out because running, biking, infected foot. Anyway, so I don't have a book pick right now, but I am going to be putting out some more content about this, and you can go find that at topenddevs.com/podcast. But what I'm working on lately is a system to help people level up. And I feel like there's kind of a multi-pronged approach that people can take for this. And so if you're interested in creating content for developers, I'm looking at 3 different kinds of series. One of them is going to be kind of the longer form course that everybody's kind of used to. But when I was learning how to program, a lot of the videos that were really helpful for me were the half-hour to 1 hour. Hey, here's how you do this thing. And so I'm going to be putting a lot of that stuff together as well. And then the other ones that were really helpful for me were the ones like Rails casts back in the day. And they were like 15-minute videos where it was, hey, here's how you do this thing real quick. And then you'd get another one. Eventually he was doing 2 a week because one was paid and one was free. And so I'm looking at doing something very similar to that model. It's all at topenddevs.com. I'm running a special through the end of November for Black Friday. And I realize that this may go out right after that, but you can sign up for 50% off at topenddevs.com and start getting access to that. I'm going to be doing master classes up through the end of the year that you can join in on or watch the replays on for various things related to your career and leveling up and learning and things like that. And there might be some widely applicable things that I put in there, like Docker or some of the other tools out there that the developers can use. Maybe we'll do a once through masterclass on VS Code, for example. But anyway, and then January, I intend to launch my first longer course. February, the same thing. March, the same thing. And the whole list will be up on topenddevs.com. And then finally, I'm going to be putting out series on leadership and career growth. And then I may pick a technology that I know well enough to do the ongoing series on, or I may just start at the beginning and say, here's the basic weekly stuff, but put those videos out as well. We're also adding a Slack channel where you can get help. There's going to be a way for you to connect with other people who are part of the community. And anyway, tons of great stuff coming. So if you want to be involved, go to topenddevs.com and just sign up. If you want to author one of these, right? So it's like, hey, I want to be doing the series on React or Angular or whatever. I think I'm going to beg Dan to do one. But anyway, I'm also going to beg AJ to do one and Steve to do one now that I'm thinking about it. But anyway, so if we can get these series going and you want to author, basically my plan is there's going to be a certain percentage of incoming revenue We'll split it up according to how many minutes of your videos people watch, right? So if you're doing the ongoing stuff, I think you'll probably get more minutes than people who do the shorter videos. Who knows, right? It may be a hot topic that people just need to learn in an hour. But anyway, so if you're interested in being a part of that, go to topenddevs.com/author. You can just fill in the form. I'll get an email. I'll get back to you and we'll figure it out. But yeah, I'd love to get some of this stuff rolling so that when we launch at the beginning of January, there's plenty of content in there and the community is moving along in a way that will help you level up. Because my mission, my goal is to get you on the path to becoming top 5% developer in your field, whatever that is, React, Ruby, JavaScript, whatever, right? Wherever you want to be, and then get you the outcomes that you want from your career. And that could be salary, it could be lifestyle, it could be I want to be home for my kids at a certain time of the day. I mean, whatever. But let's get you there. And, you know, it's not so hard that you have to go and be this meta genius across all these ideas. So anyway, topenddevs.com, that's where it's all going to live. The podcasts are moving over there right now. In fact, they're mostly moved over. So you can just go over there and click on any of the podcasts that we have. And then if you have other ideas for other technologies that we're not covering right now, feel free to let me know as well. The Slack channel will be free, so you can get in that for free. There's just going to be some premium channels that people can get into if they're paid members. Anyway, that's what I've got. I'm super excited. The thing that I implemented yesterday, so I'll pick them as well because I'm super happy with them, is Auth0. So I'm using them for the authentication on this. It was way faster and easier to pull them in and then hook up like the Google and GitHub and whatever sign in than it was for me to go build it out in Rails. So I'm pretty happy with them and we'll see how that all shakes out. But yeah, those are my picks.
Wait a second. Even better than using, forget the name of it. What's
Devise?
Yeah, Devise.
So Devise is easy. The problem is getting all those other types of sign-ins. I want people to be able to sign in with whatever they want.
Devise doesn't have plugins for the other sign-ins.
It does, but you have to go and maintain that stuff. I'd rather just let Auth0 do that. So anyway, that's pretty much it. I'm looking forward to hearing from you. Also, if you want just direct coaching on any of that stuff, topenddevs.com/coaching. And yeah, we'll wrap it up here. Thanks for coming. This was terrific, Dan.
Thank you very much. I enjoyed it myself. And I get the pleasure of having a follow-up. So, double win.
Right? All right, folks. Till next time, max out.
Bye.
Adios.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CacheFly.com to learn more.
At Kroger, we know the minute a tomato is picked, the fresh timer starts. The sooner we get our produce to you, the fresher it is. That's why we've shortened the time from harvest to home for our tasty tomatoes, strawberries, and salads. So no matter how you shop, you have more time with your fresh produce. Kroger, fresh for everyone.
And now, shop what you love and save $2 on each participating item when you buy 3 or more with your card. Kroger, fresh for everyone.
Progressive presents an ad from Mom.
What does it say here? Bundle your home and auto insurance with Progressive and get protection round the clock. You know what? I'm sorry. I think it should be around. What are you signaling? Me to stop talking? Oh, all right. I'll stop talking. No, just had to tell me. That's all you had
Get
to do.
round-the-clock protection when you bundle and save with Progressive. It's easier than getting your mom to make this radio ad. Progressive Casualty Insurance Company, affiliates, and other insurers. Discount not available in all states or situations.